In this example, we will use Inspyra to interactively explore optimization strategies to achieve a selective inhibitor of DPP4 with appropriate physicochemical properties. Starting from a dataset of compounds representing 3 chemical series, we will explore approaches to expand on diversity and consider design strategies around a specific compound of interest. In StarDrop, load the QSAR models for activities of DPP2, DPP4, DPP8 and DPP9 by selecting Open from the File menu. You can select all 4 models by holding down the Control key on Windows or Command key on macOS. Changing to the Models area, you can see that these models have been added to the list of custom models under the name of the directory from which they were loaded. Then open the project file DPP4 project by selecting Open from the File menu. This project contains a dataset called DPP4 series with 206 compounds from 4 series and experimental data for activities against DPP4, 2, 8 and 9. The dataset also includes predictions for the PIC50 values for these 4 isoforms and some simple physicochemical and ADMET properties. Furthermore, the compounds have been scored using a multi-parameter profile for a selective DPP4 inhibitor. With good solubility and human intestinal absorption, lipophilicity in an appropriate range, and good selectivity over inhibition of the ERG ion channel. We will now use the Inspyra panel to explore potential optimization strategies based on the compounds in this dataset. To open the Inspyra panel, click on the arrow button in the bottom right of the dataset. The Inspyra panel shows 5 ideas generated from the compounds in the dataset. By default, the property chosen for optimization is the selective DPP4 inhibitor score. For each compound idea, the score is shown along with a histogram indicating each property's impact on the score. This can be changed by selecting a different option from the property menu above the panel. A red border around an idea indicates that the score of that idea is higher than the average for the dataset, while a blue border indicates that the score of the idea is lower than the dataset average. The intensity of the color indicates the magnitude of the increase or decrease. Approximately every 30 seconds, one idea in the panel will be replaced by a new compound. You can interact with an idea in the panel by pointing at it. The pin button in the bottom left will prevent the idea from being replaced so that you can consider it for a longer period. In the top left, buttons enable you to provide negative feedback on the idea. The dislike button provides strong feedback that you dislike the properties or structure of the compound. The ignore button provides feedback that the idea is not of interest, even if there is not a strong reason to dislike the compound. The buttons in the top right enable you to provide positive feedback. The like button indicates that this is an interesting idea, but not good enough to retain. Finally, the select button will add the idea to the dataset and provide strong, positive feedback. Clicking on any feedback buttons will result in the idea being replaced with a new one. If you have added the idea to your dataset, this compound will also be used to generate new ideas. As you interact with the ideas in the panel, Inspyra will learn from your preferences in terms of property ranges and structural diversity, and increasingly suggest more ideas that match your preferences. In this example, we are interested in compound ideas that increase the overall score, indicating a greater likelihood of achieving the balance of properties that we require. If you see a compound with a blue border, click on the dislike button. You may choose to ignore or dislike compounds with a gray border. For compounds with a red border, click on the like button. If there is a very good idea with a strong red border, you may choose to select the idea and add it to your dataset. You will find that the panel will quickly begin to display more ideas with a strong red border and hence higher scores. If you preferentially select or like ideas from one chemotype, you will also find that the ideas appearing in the Inspyra panel will more commonly be based on that chemotype. When you're finished exploring, close the Inspyra panel by clicking on the arrow button in the top right. We will now use the Inspyra Designer to explore optimization strategies around a single compound, generating ideas for new substitution or core and linker replacements. Click on the Design tab to change to the Interactive Design area. Select row 5 from the table. This compound has a predicted herd liability, as indicated by the lower pink bar in the scoring histogram. The structure of the selected compound will be displayed in the design area. We can manually edit the structure to consider potential modifications to improve the predicted herd inhibition. However, the Inspyra Designer can propose replacements for regions of the compound to achieve this goal. Choose ERG-PIC50 from the property menu in the bottom left of the designer. Then click on the first button below the designer to activate the Inspyra Designer. Left-click and draw around the anisole group at the top of the structure. The message generating suggestions will appear in the bottom left of the designer. After a brief period, 3 suggested replacements for the anisole will appear in circles adjacent to the anisole group. Hover over a suggestion and scroll with the mouse wheel to reveal additional suggestions. As you wait, more ideas will be generated and you can scroll further through the list. The replacements have borders that are colored in the same way as the ideas in the Inspyra panel. A red border indicates a substitution that is predicted to increase the herd inhibition, and a blue border indicates a substitution that decreases the predicted herd inhibition. If you point at a suggested substitution, you can interact with it in a similar manner to the ideas in the Inspyra panel, to dislike, ignore, or like a suggestion. You can select a suggested substitution by clicking on it. Click on a suggestion with a blue border that is predicted to decrease the herd inhibition. The selected substitution will be made on the compound in the designer to generate a new structure, and the properties of this new compound will be calculated and displayed below. The predicted ERG-PIC50 of this new compound is lower than the original. Suggestions for further substitutions based on the new compound will be generated and displayed. You can click the arrow button to add a new compound idea to the dataset and store it permanently. Selecting other regions of the compound will enable you to explore other potential modifications. We'll now explore the fragmentation mode of the Inspyra Designer. Select the compound in row 6 to replace the compound in the designer. Click on the second button below the designer to enter fragmentation mode. The compounds will be automatically fragmented into rings, linkers, and substituents, and replacements will be suggested for each fragment. Over time, more suggestions will be generated for each fragment. Initially, one region will be automatically selected, in this case, the phenol ring at the top of the compound. As before, you can scroll through these ideas using the mouse wheel and ignore, dislike, and like suggestions. If you like a suggestion, by clicking on the like button, this will be remembered and you can like multiple replacements for each region. Choose some suggested replacements for replacement of the phenol ring by liking them. Now click on the phenol ring in the middle of the molecule to view the suggestions for this region. Again, choose some suggested replacements by clicking on the like button. Feel free to explore more regions of the compound and choose some replacements. Finally, click the arrow button and this will add compounds to the dataset, corresponding to every combination of the replacements you have liked for each region of the compound. The assumption underlying fragmentation mode is that if replacements for different regions of the compound are interesting, it is likely that the combinations of these replacements will also be worthy of consideration. The first part of this work example has illustrated how you can interact with Inspyra in different ways to generate suggestions for new compound ideas and substitutions around individual compounds. In the next work example, we will illustrate how you can use the Inspyra panel in combination with match series analysis.